Above Cusco, Peru, there's a wall built from stones that shouldn't exist, some weighing over 125 tons, cut and fitted with joints so tight you can't slide a knife blade between them. No mortar, no metal tools, no wheels, just stone on solid rock for 500 years, and it's outlasted every major earthquake that's hit the region since. For centuries, nobody could fully explain how it was done. In late 2025, a new geological study finally offered a real answer, and it's stranger and smarter than ancient mystery. Sacsayhuamán sits in the hills directly above Cusco, the former capital of the Inca Empire. It was built in the 15th century under the reign of Inca Pachacuti as part of a massive expansion of the Inca capital. Most of what's visible today are the outer defensive walls, three-tiered, zigzagging ramparts built in stepped terraces that face the city below. The largest stones in the lower tier are the ones that draw the eye and the questions. Construction is generally dated to the reign of Pachacuti, starting around 1440 SCE, with major work continuing under his successors into the early 1500s. The Inca Empire at its height stretched over 2,500 miles along the Andes, and Sacsayhuamán was one of its most ambitious building projects, requiring stone quarried from sites several miles away, some at higher elevation than the build site itself. The Spanish conquest in 1532 halted further Inca construction, but by then the walls that remain today were already standing and already precise. The most widely accepted explanation is also the most labor-intensive: ramps, ropes, and raw human effort. Earthen or stone ramps built at a gradual incline would let workers drag each block into position. Teams of hundreds, some estimates run into the thousands, would haul the stones using rope made from maguey and ichu grass fiber, with timber levers used to adjust final position. It's not exotic. It's just an enormous, coordinated act of labor mobilization, something the Inca state was extremely good at. Their empire ran on organized labor tribute called mita. A second theory proposes log rolling, placing timber logs beneath each block so it could be rolled rather than dragged, similar to techniques associated with ancient Egyptian construction. It's mechanically simpler in principle, but Sacsayhuamán's terrain works against it. The ground between likely quarry sites and the build site is steep and uneven, which would make sustained log rolling difficult without extensive groundwork. Most researchers haven't found evidence for. It hasn't been ruled out for shorter stretches, but as the primary method for the largest stones, it doesn't fully hold up. Here's the theory almost nobody covers. Some of the precision may not be craftsmanship at all. It may be smart selection. In December 2025, a geological study of the stones themselves found something unexpected. Pillow-like bulges, curved corners, scoop marks, and surface textures that pointed to natural processes, not just hand carving. The Inca builders, this theory argues, weren't purely cutting stones to fit. They were choosing stones already naturally shaped by geological weathering to interlock well, then refining the fit from there. Adaptation, not pure mystery. Because the precision looks so far beyond expectation, Sacsayhuamán has picked up its share of fringe claims over the decades, including theories involving lost advanced civilizations or even extraterrestrial help. It's worth naming these because they're genuinely part of the site's popular mythology. But they don't hold up against what we actually know. Inca stonework elsewhere at smaller and more verifiable scale shows the exact same techniques. pecking, grinding, and precision test fitting just scaled up here to their most ambitious project. The mystery isn't unexplainable, it's just enormous. Two pieces of recent research change the picture. First, the December 2025 geological study on material selection. Second, a 2025 structural engineering study modeled a Sacsayhuamán wall section using finite element analysis, treating the stones as rigid bodies to simulate how the wall behaves under seismic stress. The result? The irregular, tightly interlocked joints aren't just aesthetically impressive, they let individual stones shift and resettle slightly during an earthquake, rather than cracking. It's very possibly the reason these walls have survived 500 years of Andean seismic activity that has leveled colonial Spanish buildings built right next to them. So, the wall isn't magic, it's not aliens, and it's probably not a lost super technology either. It's a combination most people don't expect. An empire that could mobilize thousands of coordinated laborers, stoneworkers who understood their material well enough to choose it strategically, not just cut it by brute force, and, whether by design or fortunate consequence, a joint structure that happens to be extraordinarily earthquake-resistant. Sacsayhuamán doesn't need an unexplainable answer to stay impressive. What we now understand is a civilization that combined empirical material science with immense organizational capacity, and possibly built in a resilience feature we're only now able to explain with modern engineering tools. The stones were never magic. They were just centuries ahead of anyone giving the builders credit for what they actually knew.